Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ogobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 3, still on intermolecular forces and physical properties. It says the table below shows the relative molecular masses, melting points and boiling points of a few substances. And then as we can see the table here, we are given like that. Then 3.1 says define the term melting point. So we have already defined it multiple times already. So 3.1 we say melting point is the temperature at which the solid and liquid phases of a substance are at equilibrium. Right. So the temperature at which the solid and liquid phases of a substance are at equilibrium, we call that the melting point. Okay, so let's now check. 3.2 says from the substance in the table, write the name or formula of two substances that are liquids at room temperature. Now, we've already discussed a similar question. We said every time we are looking for substances that are liquids at room temperature, we look at the boiling point, and then what we are looking for is that the boiling point, remember room temperature. What is room temperature? Again, let's understand room temperature is 25 degrees Celsius. Right. So I said it in the previous video that sometimes they will not write 25 degrees Celsius, they will write the term room temperature. So understand when they're talking about the room temperature, they're talking about a temperature of 25 degrees Celsius. Now, in order for us to identify two substances that will be liquid at room temperature, that means we'll be looking for substances that will have a boiling point at a temperature that is greater than 25 degrees Celsius. So we are looking for the boiling point to be greater than 25 degrees Celsius. And then which two substances have a boiling point that is greater than 25 degrees Celsius? As we can see, it is pentane and heptane. So 3.2.1, we are going to tell them it's pentane and heptane. Right, then 3.2.2, they're saying the substance with the highest vapor pressure. Now, according to our relationship, we are only given the melting point, boiling point, but we do know that vapor pressure is inversely proportional to the melting point and also inversely proportional to the boiling point. So that means if you are looking for the one with the highest vapor pressure, then we must be looking for the one with the lowest melting point, or again, we must be looking for the one with the lowest boiling point. So whether you check boiling point or melting point, then you should be correct. Let's check which one is the lowest boiling point. We can see that it is obviously our propane. So we're going to write propane, right? And then 3.2.1 saying, give one substance that is a gas at room temperature. Now, if it is a gas at 25 degrees Celsius, that means its boiling point must be less than 25 degrees Celsius. In order for that substance to be a gas at room temperature, then it must have a boiling point at a temperature that is lower than the room temperature. So we can see that we have two substances. It can be the propane, it can be the butane. So either one of these would be correct. So you would say propane or you would say butane, right? So either one of these two would be correct, guys. Then, okay, let's now move. We are looking at 3.3. It says propane, butane, pentane, and heptane are non-polar molecules. They are what? Non-polar molecules. So that means they have a dipole moment of 0, right? So the electron density is shared equally amongst the atoms, right? Then 3.3.1 says, name the type of van der Waals forces present between these molecules. Now, guys, I want you to note this. So these questions here, this topic as a whole in intermolecular forces relates very much to the atomic combinations. So do not treat them like two very different topics. They do share some of the aspects in them. So you might find a question that is based on atomic combination while we are doing intermolecular forces. And still, when you are solving atomic combination questions, you can still get a question on intermolecular forces. So these two topics are interrelated, right? So name the type of van der Waals forces present between these molecules. So the van der Waals forces are the weak forces. So what are those type of van der Waals forces that we have in these nonpolar molecules? We obviously know if a molecule is nonpolar, then it obviously has the London forces. Then 3.3.2 says, state the trend with respect to what? To the boiling points of these compounds as shown in the table. So now, looking at the boiling points, we can see that our boiling points are increasing, going down here. But then why are they increasing? It's because when we look at the molecular size or the molecular mass, we can see that the molecular mass is also increasing, going downward there. So boiling point increasing, going down, and then also the molecular mass is increasing, going downwards. So the trend could be what? The boiling point, you can say the boiling point increases. So let's say the boiling point increases with an increase in molecular mass. So that's the trend. That's the trend that we observe here. The boiling point increase with an increase in molecular mass. So as much as we are increasing in molecular mass, also the boiling point increases. Then for 3.3.3, they're saying explain the answer to question 3.3.2 by referring to the strength of the forces and the energies involved. Remember, we have now already identified that all of these are London forces, and then also the part that the boiling point increases with an increase in molecular mass. So what we can do to explain is to tell them that the London forces increases with an increase in molecular size, in molecular mass, which means more energy is needed to overcome the London forces in larger molecules. Now, obviously, if more and more energy is needed as the molecules become larger and larger, that means this will eventually increase our boiling point, since we are saying the strength of those London forces is increasing, right? So that's how we just explain for the 2 marks. We just say London forces increases with an increase in molecular mass, and then that means more energy is needed or required to overcome those intermolecular forces or to overcome those London forces as the molecules become larger and larger, right? So that's how you are supposed to explain that. And then that's how you were supposed to tackle all of that question for 11 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.